Hey everyone! In this video we're going to look at a one-dimensional elastic collision, and in our first example we're solving for velocity. Let's go through the question and identify the key pieces of information. We have Becky, who's our first little object here, and Becky has a mass of 60 kilograms and is running east at 4 meters per second when she bumps into Donna. Becky and Donna always bumping into each other. Donna has a mass of 85 kilograms and was running west at 3 meters per second. Now, after this collision, Donna bounces backwards, that's going to be important in a moment, at 2 meters per second. What velocity does Becky have after this unfortunate collision? So let's start off by writing out the equation for momentum. We have m1v1 plus m2v2 is equal to m1v1 prime plus m2v2 prime. And we're going to go through what these mean and how you can fill them in. Well, the first thing is m1 is the mass of our first object, in this case, Becky. So we can go ahead for m1 and fill in 60. m1 is the mass of our first object. v1 is the velocity of our first object. In this case, Becky is running east. East is the positive direction because it's to the right, so we can just fill in 4. Plus our mass 2. This is the mass of whatever object 1 is colliding into. In this case, our mass 2 is Donna. We can fill in 85 kilograms. And we need to know Donna's velocity. Here's this part where it's important that it's west. If we've decided that Becky is going east at 4 meters per second, and that's a positive 4, Donna, who is running west, which is, you could think of that as to the left if you're looking at a grid, that's going to be a negative 3. It's the other direction. If you make them both positive, you're going to get some wonky answers. They can't bump into each other. They go in opposite directions, and that's why they collide. This is going to equal m1, once again, back to the mass of Becky. 60. v1 prime. This is where my students ask me, what does this little apostrophe mean? This prime symbol means after some event. In this case, the event in question is Becky and Donna colliding. So what we're looking for is the velocity of Becky after they collide. But that's actually what we're looking for. We want to find the velocity of Becky after they collide. So we're just going to leave that as a variable and keep going. m2 is the mass of Donna. We know that's 85. And v2 prime, this little symbol right here, means the velocity of Donna after the collision. Now, I said that this backwards was going to become important. This is backwards to Donna. So if Donna was running to the left at 3 meters per second, which was why it was a negative 3, if Donna bumps into Becky and then falls backwards, her new velocity is now positive 2 because it's in the direction that Becky was running. Becky was running 4, thumps into Donna, whump, and now Donna bounces in the direction that Becky was running at 2 meters per second. If you filled this in correctly, you should only have one unknown. This is by far the hardest part of the question, because now that you've done this, this is all going to tidy up. That's just 240. Multiply the 85 and the negative 3, you get minus 255 is equal to 60 v1 prime, and that tidies up as well, plus 170. All we need to do is bring all of these terms over to the left. I'm going to subtract 170 and subtract 170. And this is going to leave me with a nice and tidy negative 185 equals 60 v1 prime. But once you see, if you take the time to fill them all in and make sure that your directions are right, the actual algebra for a collision, that isn't so bad. In order to finish this off, we have to get rid of this 60. divide by 60, divide by 60, v1 prime, which is the velocity of Becky after the collision, is negative 3.1 meters per second. This makes sense because Becky was running 4 meters per second east. If she bumped into Donna and fell backwards, it now makes sense that her velocity is going in the opposite direction that she was originally going. So just like Donna went from a negative direction to a positive direction, Becky went from a positive direction to a negative direction. Let's do one more of these where we're solving for mass. All right, now we have a brand new elastic collision question, but this time, instead of solving for an unknown velocity, we're solving for an unknown mass. We're going to go through and highlight key information. So we have a ball, and it's rolling east at 10 meters per second. And if you were just watching the last example, you'll know that we typically treat east as our positive direction. So this is going to be a positive 10 meters per second. It bounces into a second ball that is 2 kilograms that was going 5 meters per second west. That means when we fill this into the equation, we're going to have to remember that is a negative 5 meters per second. After the collision, this is when the prime notation is used. Some event has happened. The balls have collided. The second ball returns in the direction it came at 1 meter per second. That means it's going to, if it was going negative, now it's going to be positive. The first ball also bounces backwards, but at 8 meters per second. That means it will also change its direction. What is the mass of the first ball? So we're going to go ahead and get our equation up. m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime. And if you have a nice teacher, maybe they'll give you this equation for the test. Usually you wouldn't make folks memorize this one, especially if they're just starting in with physics. But you never know. We need to fill everything in now. m1 will be the mass of the first ball. But we're stuck because we're actually looking for the mass of the first ball. So this is an unknown right from the very beginning. We do know the velocity, v1, of the first ball in the beginning. That was east at 10 meters per second, which means a positive 10. m2 is the mass of the second ball, and we know that that's 2 kilograms. v2 is the initial velocity of that second ball. That's 5 meters per second west, and we remember now that because it's west, it's going to have to be a negative 5. You watch a couple of these examples and you'll be doing this in no time. We're back to m1 again. Oh, still an unknown. Not a fan of multiple variables, but I think we'll be fine. v1 prime is the velocity of ball 1 after the collision. And it says the first ball bounces backwards, but at 8 meters per second. That means because it was positive, if it bounces backwards, that first ball is now going to have a velocity of negative 8. Watch those little keywords as you're doing this. m2 is still the mass of our second ball. It returned in the direction it came at 1 meter per second. The second ball was going negative. If it bounced backwards, that is now a positive. The hardest part of these questions is making sure that you have all of your numbers filled in correctly, because once you've done this, watch how tidy this gets. Even though we have two variables, we're going to be able to simplify this and combine like terms. We're going to end up with 10 m1 minus 10 is equal to negative 8 m1 plus 2. And watch how quickly this is going to tidy up. I want to bring this 10 over to the other side, so I'm going to just add 10 to both sides, and I want to bring this negative 8 m1 and bring this over to the other side. So I want all of my m1s on one side, and I want all of my other terms on the other. And what we're going to end up with is 18 m1 equals 12. We went from this big mess of numbers right to 18, m1 equals 12. In order to get rid of this 18, divide by 18, divide by 18, and you get your final answer, m1 equals 0.67 kilograms. And just like that, we've solved one-dimensional elastic collisions, both for velocity and for mass. I hope that this was helpful and that you can work on doing these questions now all on your own. If you have any questions about this, please feel free to leave a comment down below.